Greetings everybody. This is the third video that goes with the first practice exam for exam number 2. And problem 5, it's an inclined plane problem. We've seen it a couple times in the notes where you have a crate, and we know the numbers, we know the mass, we know theta, we know the magnitude of the pushing force. So it's being pushed up the incline at a constant speed by this pushing force P. This force is parallel to the ground, not to the incline. So in other words, P is in the original positive x direction. So I know theta, I know the mass of the crate, I know the magnitude of the pushing force, and I want to find the coefficient of kinetic friction between the crate and the incline. I want mu k. Well, I know mu k will be Fk over Fn. Well, let's go ahead and let's solve this. Okay, so we want the coefficient of kinetic friction, that's mu k. We want the coefficient of kinetic friction mu k between the crate and the incline. And we know the incline is the crate is being pushed up the incline at a constant speed by that pushing force. Well, let's go ahead, let's draw the other forces acting on the crate, then apply Newton's second law. Well, here we go. Here's this figure here. There's my horizontal pushing force that's in the positive x direction. Okay, here's mg, here's the weight of the crate, and then here's Fn. That's the normal force of the incline on the crate. So I have P, mg, and Fn. Well, again, mg, let's get its components. Again, the x component is mg sine theta, y component mg cosine theta. Now, by now, it shouldn't be a stretch. If the angle of the incline is theta, again, I know this angle I use to resolve mg is theta. The angle I'm using to resolve p is also theta. That's very easy to prove geometrically. So now let's look at p. Well, the y component of p is p sine theta, but negative, notice, and the x component of p is p cosine theta. Why is this p sine theta? Because it's opposite to the angle. Why is this one p cosine theta? Because it's the adjacent side. Okay? Now I also have friction. Because again, if you have coefficient of friction, that means you darn well better have a friction force. Well, the crate is being pushed up the incline, so Fk is going to be directed exactly opposite. So Fk is going to be down the incline. Now remember, because the crate is being pushed up the incline at a constant speed, I indicate here v equals constant with this dotted arrow, that's the positive x direction. So in terms of the x direction, p cosine theta is positive. Fk and mg sine theta are negative. In terms of the y direction, nothing complicated. Fn is positive, p sine theta and mg cosine theta are negative. Again, how did I know how to do the components of p? Well, remember, I'm going to need to go, the vector p, I'm going from here to here. I have to go down in the negative y and then up in the positive x. Okay, so we're good. So now remember, Fk equals mu k Fn, mu k equals Fk over Fn. So I need an equation for Fk and an equation for Fn, and then just divide those two equations. Again, that's always going to be the case, as indicated in that red box. Okay, well, let me apply Newton's second law to the crate in both the x and y directions. Well, in the x direction, I have p cosine theta is positive, mg sine theta and Fk are both negative. So I have p cosine theta minus mg sine theta minus Fk equals 0. Or right away, because of this condition, v equals constant, right away you could state, well, no, this is fine. Let's leave it like this. I'm babbling a little bit. Just leave it like this. Again, p cosine theta is positive because it's up the incline. mg sine theta and Fk are negative because they're directed down the incline. and that the sum of those three forces has to equal 0 because the speed of the crate is constant. Now, on an inclined plane problem, you'll never have an acceleration in the x direction. So I know that Fn minus p sine theta minus mg cosine theta has to equal 0. Because there are three forces acting on the crate in the y direction. Fn is positive, p sine theta and mg cosine theta are negative. So Fn minus p sine theta minus mg cosine theta must equal 0. Okay? Now I want to solve equation 1 for Fk and solve equation 2 for Fn. So very simple. I get equation 3 and 4. Fk is p cosine theta minus mg sine theta. And then Fn is p sine theta plus mg cosine theta. Then mu k is Fk divided by Fn. In other words, equation 3 divided by equation 4. Because mu k is Fk divided by Fn. So it's equation 3 divided by equation 4. That's what I have right here. Plug in the numbers, because you know m, you know theta, you know p, g is 9.80, and you get a coefficient of kinetic friction of 0.234. I mean, by now this should seem like a relatively straightforward inclined plane problem with friction. Alrighty, let me go ahead and get this video saved and get it posted.